signals and systems is one subject which is fundamental in all circuit branches. It actually is the basic part of communication theory also. Once you have proper knowledge about the concepts of signals and system, it will become much easier to learn communication systems as well as control systems. Okay, so we'll start off with signals and systems here. We'll be discussing the classification of signals and classification of systems today. Okay, so we'll discuss the signals classification. Okay, and systems classifications today, right? Okay, so in signals, generally we classify it based on the different properties of a signal. So the general classifications I'll list out first. We'll look into each classification in detail. So the first classification normally is continuous time signals and discrete time signals. Continuous and discrete time signals. And the second classification is normally periodic and non-periodic signals. Periodic and non-periodic signals. Okay. Periodic and non-periodic signals. And the third classification is, these are classifications based on which normally questions will be asked in competitive exams. Even and odd signals. Even and odd signals. Then we have energy and power signals. Energy and power signals. Then deterministic and random signals. Deterministic and random signals. Sometimes you call probabilistic signals also. Random signals are based on probabilistic models. Probabilities. Probability based models. Okay. Then another classification is there: causal, non-causal, or anti-causal signals. Okay, so we'll be discussing everything in detail. First one is continuous and discrete signals, then periodic and non-periodic signals, even and odd signals, energy and power signals, deterministic and random signals. Then the last one is causal, non-causal, and anti-causal signals. Similarly, for systems, we have different classifications. The first classification is linear and non-linear systems. Linear and non-linear. Okay, so generally we'll be more looking into the linear systems in detail, because almost all of the engineering systems which we deal with will be linear systems. We rarely use non-linear systems. So, but we'll learn what is meant by non-linear system. But all the systems which we learn in engineering, at least in BTech or MTech level, is linear systems only. Okay. The next classification of systems are causal and non-causal systems. Causal and non-causal systems. Okay. Causal and non-causal systems. Then we have dynamic and causal systems. Sorry, dynamic and memoryless systems. Dynamic and memoryless systems. So from the word itself, dynamic means systems which has got memory, and the other system is memoryless. And one more classification is stable and unstable systems. Okay. And along with linearity, you might have learned about one more term which is associated with linearity, that is time invariant and time variant systems. Time invariant and time variant systems. So in general, for the lecture and poly syllabus, we'll be covering these classifications in detail. about signals and systems. Okay, so we'll move on to the first classification of signal, which is continuous and discrete signals. Okay, continuous and discrete. If you want time to take down the notes, you can ask me in chat, or you can unmute and ask any doubt during the session, right? If I do not receive any chat request, I'll assume that you are following me, and I'll proceed. Is it okay? Right. So we'll discuss continuous and discrete time systems in detail, discrete time signals in details. Okay. So continuous and discrete signals. Continuous and discrete signals. Okay. So what is meant by a signal? First of all, a signal is basically any function of time. It is a function of an independent variable. Normally, the independent variable is time. In most of the cases, we'll be using time as the independent variable. And the dependent variable can be any physical parameter which carries some information. It could be pressure, it could be force, or it could be electrical signals. But in our case, or in the case of circuit branches, we will be normally using voltage or current variable as the y-axis variable, or which is the dependent variable. So I'm using the term x of to indicate x of t. So here t is the independent variable, and x of t is a function of time, which is the dependent variable. So continuous, the term means the term continuous is defined with respect to the independent variable. Okay, so if I have something which is continuous in time, okay, that means for time axis, for all particular values of time axis, it is defined. That is what is meant by continuous in time. And it could be discrete or continuous in amplitude. For example, suppose I have a signal like this. Okay, this is a continuous in time as well as continuous in amplitude signal. Whereas suppose I have this kind of signal. Okay, the second kind of signal, this is a signal which is continuous in time, but in voltage level or in amplitude level, it is having only some discrete values. So the word continuous is actually referring to continuous in time. Okay, so if the values of amplitude are varying continuously, that is actually called as continuous and analog signal. So this is continuous and analog. Okay, and this is continuous and digital. Right? So this is what is meant by a continuous t, and I have values for the signal at 0, at an instant 1, at an at 1 point you will have another value, at 2 point you will have another value, and 3 point you have another value. This kind of a signal is called as a discrete time signal, which means in along the time axis, it is not continuous time. It will be, we will not use the term small t here. We'll be using the variable n. It is actually indicating a number, and that number is specifying. 1 second. If somebody is joining in between, I need to switch back to the other screen. Okay, if the value of n is not continuous with respect to time, it is actually discrete values only. And if I take n is equal to 3, that means 3 times the interval, right? So this is an example of a discrete time signal. So it will be normally represented by x of n, and n will take integer values. Okay, now we'll see some examples for continuous time signals. For an example for continuous time signal x of t is, you can say easy example. Suppose I take the signal sine omega t. Omega is unknown, but we know the variable time is continuous, and the function is also continuous here. So it will be something like this, right? You have seen the sine wave. This is a waveform which is continuous in time, right? And for example, discrete time signal example is, suppose I have x of n equal to let us call unit step function u of n. We'll define what is unit step function later. For the time being, you just understand unit step function is any function which is having values of 1 at all particular instance of n, right? These are actually impulses at n, impulses at all particular values. So 0, 1, 2, 3, 4, 5, every value it will be 1, right? 1 second. Yes. 1 second. I need to add another person. Okay, this is Miss. Actually, I have sent a request by 3:30 itself, so that if anybody did not receive it, I could have avoided this interruption. But just now they are looking into the messages, so whenever there is class, it is better you at least check the WhatsApp group by 15 minutes before the class, at least 15 minutes before the class, so that there won't be any interruptions during the class. Okay, right. Okay, we will continue. So this is an example of discrete time signal. This is an example of continuous time signal. Okay, now we'll move on to the next classification of signals, which is periodic and non-periodic signals. Okay, so the second classification is periodic and non-periodic signals. Periodic and non-periodic signals. So one important thing is, basically we will learn a lot of classifications, but these continuous and discrete and periodic and non-periodic are very important. So I'll ask you to remember these letters. C will be representing continuous, D will be representing discrete, P will be representing periodic, and N will be representing non-periodic. Okay, this is very important because you can generally classify any class of signal into a combination of these letters. Okay, because I can take continuous and periodic signal, I can take continuous and non-periodic signal, I can take discrete and periodic signal, I can also take discrete and non-periodic signal. Okay, so these four classes are very important. These four classes are very important because all the analysis tools which we use in signals and systems are classified based on this classification. This continuous and periodic, continuous and non-periodic, discrete and periodic, and discrete and non-periodic. For example, if you take the important analysis which you learn in signals is Fourier analysis. You might have learned about Fourier series as well as Fourier transform, right? See, transform is used whenever you have non-periodic signals. So this will be the time you use Fourier transform. Okay, and whenever there is periodic set, it is series. Okay, so for continuous periodic, it will be continuous time Fourier series. For discrete periodic, it will be discrete time Fourier series. For continuous non-periodic, it will be continuous time Fourier transform, and for discrete non-periodic, it will be discrete time Fourier transform. Right, that is the importance of this letter combinations. So this four class will have different sets of equations for analysis and synthesis in Fourier analysis. That is why I told you need to remember these letters as continuous, discrete, periodic, and non-periodic. Okay. Now we'll listen to what we will learn what is meant by actually periodic and non-periodic signals. This is very important because for almost all competitive exams, if there are questions from this basic part, one of the area which they mostly focus is periodic signals and non-periodic signals. Okay, so what is meant by periodic signal? We will take the case of continuous periodic case first. For example, if a signal h of t obeys the relation h of t plus capital T equal to h of t, that is, the pattern of that signal is repeating with respect to time. Okay, the pattern of that signal is repeating with respect to time. If this equation is obeyed for any signal over the time, this is very important, over the time interval minus infinity to plus infinity. If it is repeated over minus infinity to plus infinity, then it is called as a periodic signal. Then it is called as a periodic signal. And the minimum value of, this is important, the minimum value of t, minimum value of capital T, which obeys this relation, is called as the period of signal. Okay, which obeys this relation is called as a period of the signal. So this is important. The minimum value of capital T which obeys this equation is called as the period of the signal. Okay, I'll take an example for this particular periodic signal. For example, suppose we all know sinusoidal signals are periodic signals. Okay, for example, I'll take the signal x of t equal to, let us say, sine 3 pi t. Okay, I'm taking this example of sine 3 pi t. Let us check whether this signal is periodic or not. So the condition which need to be satisfied is x of t must be equal to, or x of t plus capital T must be equal to x of t. Correct? X of t plus capital T must be equal to x of t. 1 second. Right. X of t plus capital T must be equal to x of t. Now, if you apply this relation into the signal, it should give me sine of 3 pi into small t plus capital T must be equal to sine of 3 pi t itself, right? Because this is what it means. Okay, this is what it means. 1 second. Hold on 1 second. Okay, right. And now, so if you expand this, it will become sine of 3 pi into small t plus 3 pi into capital T will be equal to sine of 3 pi t, right? Now we know the trigonometric relation sine of theta plus 2 pi will always be equal to sine theta, correct? Sine of theta plus 2 pi will always be equal to sine theta, which means if I have this relation applied into this equation, sine of 3 pi t plus 3 pi into capital T equal to 3 pi into small t, which means this must be equal to, according to this relation, this must be equal to 2 pi, correct? So 3 pi into capital T must be equal to 2 pi, which means capital T must be equal to 2 by 3, right? Now, you can say this is the period of this particular signal. You can say this is the period of this particular signal, correct? All of you are clear about it? Any doubts? This is the fundamental idea of periodicity. If you have any doubt, you can, sometime audio is not clear. Okay. Is the audio clear now? Sometimes audio is not clear. Is there an issue with the audio? Now it is clear. At starting there was an issue. Okay, now it is clear. Okay, see, if there is any technical issues, you should immediately unmute and tell me, because I might not always look into the chat box. Okay, sometimes I'll be focusing in the board, so it is always easy if there is no issues at all. If you can you face any technical issues, please unmute and tell me. Okay, right. Okay, so this is the idea of periodicity. Now we'll see if there is a signal which has got a period of t1, and if there is another signal which has got a period of t2. Let us see what will be the period of that combined signal. Okay, suppose I have a signal h of t with a period t1, and I have another signal h of, sorry, this is h1 of t, and this is h2 of t with a period of t2. Okay, now, how will you say whether that the combined signals are periodic or not? I am taking a new signal. The new signal is, let us say, x3 of t is equal to h1 of t plus h2 of t. I know h1 of t is periodic with a period of t1. I know h2 of t is periodic with a period of t2. Now, question is whether h3 of t will always be periodic or not. How do you check whether h3 of t is periodic or not? That is the question. So, the basic idea here is we'll consider a particular example using sinusoids. Okay, I'll draw a sine wave with a period of, let us say the period of this particular signal is let us say 3 seconds. Okay, and I'll draw another signal with a period of, let us say, 2 seconds. Right, so the second wave is with a period of 2 seconds. Now, this is, suppose this is h1 and suppose this is h2. We know it is separately, it is periodic, but the question is, if I add up h1 plus h2, is it periodic or not? Now, you can see if you add up these two signals at this particular point, it will be both zeros, right? Now, this signal will again pass through 0 at 3 seconds, but this signal will again pass through 0 at 2 seconds. So, at this particular point, at 2 seconds, the sum will not be 0. At 3 seconds also, the sum will not be 0. Now, when you will get back the sum is equal to 0. If you get back the sum is equal to 0 at some particular point, you can intuitively say that if this crossing point is matching with this crossing point along the time axis at some point, you can say at that instant both the signals are having a value of 0. For example, this will cross the time axis again at 6 seconds, right? And this will cross the time axis again at, this first has crossed at 2 seconds, then it will cross at 4 seconds, then it will cross at 6 seconds, right? So at 6 seconds, both the signals are again starting from 0, which means I can say this sum of signals is periodic with a period of 6 seconds. Now, how you got the number 6? It is nothing but it is the least common multiple of T1 and T2. It is the least common multiple of T1 and T2. Now, if there is an LCM for T1 and T2 which exists, then we can say that the sum of the period, sum of the signals is also periodic, and the period is the LCM of T1 and T2. So, if you have two signals which are H1 with period T1 and H2 with period T2, then the sum of the signals will be periodic with a period equal to the LCM of T1 and T2. LCM of T1 and T2 provided if it exists. If it exists. Why did I say the this point if it exists? See, because you need not always have an LCM. For example, suppose if T1 is equal to root 2 and T2 is equal to 3. Can you find a least common multiple for root 2 and 3? You can never find a least common multiple for root 2 and 3 because root 2 will not again cut on the time axis at an integer multiple. Root 2 will be cutting the time axis at 2 root 2, 3 root 2, etc. Root 2 plus, etc. Right? And this will be cutting along the x-axis at 3, 6, 9, etc. Which means if one of the period is irrational number and if the other period is a rational number, then the sum of the signal will not be periodic. How do you easily check whether it is periodic or not? There is a thumb rule to check if it is periodic or not. You can just take the ratio of T1 by T2. You take the ratio of T1 by T2. If this T1 by T2 ratio is a rational number, if it is a rational number, what is meant by a rational number? A rational number is any number which can be written as the ratio of two integers. Ratio of two integers where P and Q are integers. Okay, if this is a rational number, then T1 and T2 will have an LCM, and the period will be LCM of T1 comma T2, and the period will be LCM of T1 comma T2. This is the idea of periodicity when you have more than one signals added up to get a single signal. Okay, this is the idea of LCM of idea of period of a signal when you have more than one signal added to get a new signal. Is it clear to you? Shall I proceed? Right. So I'll just take an example of a signal. Suppose one question is H1 is having a period of, the period of H1 is 2/5 and the period of H2 is, let us say, is 1/3. Now what is the period of H1 plus H2? Okay, this is the question. Here I have two signals. One is having a period of 2/5, another is having a period of 1/3. And my question is whether the sum of the signal is periodic. If it is periodic, what is the period? So my thumb rule is I'll always find the ratio first. Okay, I'll check whether T1 by T2 is a rational number. What is T1 by T2? T1 is 2/5 divided by T2 is 1/3. Correct? So that is equal to 2/5 into 3/1. Correct? So that is equal to 6/5. See, this is a rational number because it is a ratio of two integers, which means it is periodic. Now, what is the period? Period can be evaluated as the LCM of, period is equal to the LCM of T1 comma T2. I know LCM will exist because T1 by T2 is a rational number, right? I know LCM will exist because T1 by T2 is a rational number. So what is the LCM of T1 by T1 comma T2? See, there is a rule to evaluate the LCM. LCM of fractions is equal to, LCM is equal to, if you want to evaluate the LCM of fractions, it is the LCM of numerators, LCM of numerators divided by HCF of denominators. Okay. Now the two values here are 2/5 and 1/3. Correct. So the numerators are 2 and 1. What is the LCM of 2 and 1? LCM of 2 and 1 is 2. LCM of 2 and 1 is 2. And what is the highest common factor of HCF of 5 and 3? Highest common factor of 5 and 3 is 1. So we have this relation to evaluate LCM of fractions. LCM of this fraction will be 2 divided by 1, which is equal to 2. So my period here will be equal to, period equal to 2. Is it clear? Any doubts? Okay. Yeah.
The മൂന്ന് സിഗ്നൽസിന്റെ സം ആണെങ്കിലോ?
മൂന്ന് സിഗ്നൽസിന്റെ സം ആണെങ്കിൽ മൂന്നിന്റെ LCM എടുക്കണം.
മൂന്നിന്റെയും കൂടെ LCM എടുക്കണം. Okay.
And if you have all the fractions, then LCM of numerators divided by HCF of denominators.
Okay.
And if any of those is, see, it's very easy to check whether it is periodic or not, because you need to check if one number is rational and another number is irrational. For example, if T1 is equal to pi, okay, and T2 is equal to 3. I know this is a rational number, correct? This can be written as a ratio of two integers, 3/1. But this is not a rational number. Pi is not, pi, you cannot write, pi cannot be written as a ratio of two integers. Pi is never equal to a ratio of two integers, which means pi is an irrational number and 3 is a rational number. If one of the period is irrational and another is rational, then the ratio will always be an irrational number. Hence, this T1 T2 combination will give you a non-periodic signal. So it is easy to check whether you have a periodic signal or non-periodic signal. You need to check the period of each separate signals. If all are rational numbers, then their combination will also be rational. Okay. If one of them is irrational, then their combination will be irrational, which means you can never find the period for that particular signal. Okay. Right.
Okay, sir.
Yeah. So now we'll check whether we'll check an example of a non-periodic signal. A classic example of a non-periodic signal is we learned this signal also. I'll be introducing different examples. Those will be important signals. For example, I'll write a signal called as h of t equal to a rectangular function. The short form is RECT, rectangular function of t by tau. Okay, tau is a constant and t is the time axis. Okay, now this signal is, this is a particular signal which is very important for communication theory. Okay, we'll take this as a standard signal. This is a signal which is having an amplitude of A, and is existing from minus tau by 2 to plus tau by 2. This is what is called as a rectangular function. So an example is, suppose 4 rectangular function of t by 6. Okay, that will be having an amplitude of 4. Okay, and it will be existing from, what is tau here? Tau will be 6, right? So it will be existing from minus tau by 2, which means minus 3 to plus 3. This is a rectangular function, and this is a non-periodic signal, right? This is an example of a non-periodic signal. Another example of a non-periodic signal is x of t equal to u of t. X of t equal to u of t. Let us see what will be u of t. U of t is a function which is defined as u of t is equal to, it is 1 for t less than 0 and 0 for t greater than 0. Okay, so u of t is one function which is called as unit step function. It is a very important function. It is a function which is 1 for t greater than 0 and 0 for t less than 0. Now, if somebody asks you what is its value at t equal to 0, strictly speaking, it is not defined. Okay, strictly speaking, it is not defined. But for all practical purposes, whenever you face discontinuity, this is called as a discontinuity. For example, if you approach this signal from the right side to 0, it will be traveling from here, right? It will be traveling from here. We will approach from here. It will reach the value 1, right? If you approach this signal from the left side, you will be traveling along this value. It will reach the value 0. So at particular value of 0, there is a sudden transition. Such a signal is actually called as discontinuous at that particular point. And the value of the signal is actually not defined at discontinuity. But in signals and system, for practical uses, we can take the value of a signal at discontinuity as the average of the left hand limit and right hand limit, which means average of left hand limit and right hand limit, average of left hand limit and right hand limit. Left hand limit means what will be the value of the signal at that particular point if you approach from the left side? It is 0, correct? What will be the value of that signal if you approach from the right side? That is 1. So what is the value, what is the average of 0 and 1? That will be 1 by 2, correct? So I can write it as 1 by 2 at t equal to 0 for some practical purposes. But if you ask me the definition, it is actually not defined. For many problems, you can use 1 by 2 to get answers. There will be nothing wrong. Is it clear? Mathematically, it is not defined. Okay, so if you show this definition to any maths teachers, they will object. Their objection is correct only. It is not defined. But for signals and for engineers, you can use it as 1 by 2. Okay. So I hope this is a non-periodic signal, because it is, first of all, it is not existing from minus infinity to plus infinity. Also, it is only valid for t greater than 0. So this is a non-periodic signal. Okay. Right. I'll move on to the next definition. See, a lot of problems will be asked from periodicity and non-periodicity of a signal. I'll be conducting one tutorial session for this particular class in the next week. Can you check the equation of u of t? Which equation? Sorry. Oh, this one, right? Sorry. This is what you meant by Ajaynath, correct? I have wrongly written it. For t greater than 0, it is 1, and t less than 0, it is, sorry. This was the signal, symbol was written wrongly. T is greater than 0, it is 1. T is less than 0, it is 0. Correct? This is correct. That was a mistake. Okay. I hope, Ajaynath, you are mentioning this mistake, right? Right. For t greater than 0, it is 1. For t less than 0, it is 0. Correct only. That is what I have drawn also. Okay. Yeah. Okay. So a lot of questions will be asked from this area. We'll cover it in tutorial session. I'll be planning it as a theory session in one class. Next week, we'll conduct a tutorial for the same. So all the problems will be discussed in the tutorial session. I'll be working out just examples to understand the concept in the theory class. Okay. So I'm moving on to the next classification of signal, that is even and odd signals. Is a concept of periodicity clear to you? This is a non-periodic signal. Okay. Is the concept of periodicity clear? Yes. Okay. So I'm moving on to the next classification, which is even and odd signals. Even and odd signals. Okay, this is similar to even and odd functions only. You have learned in mathematics what is meant by an even function. Even function is nothing but h of t will be equal to h of minus t. Now you must learn taking minus t is actually equivalent to taking the mirror image. For example, suppose I have a signal like this. Suppose I have a signal like this, which is existing from 0 to 3, right? Now, what if I take the mirror image? The mirror image will be like this, right? The mirror image of this signal will be about y-axis, it will be like this. Now, if h of t is equal to h of minus t, that is, if you take the mirror image that is the same, then that kind of signal is called as an even function. It is an even signal. Okay, this is an even signal. So this is an even signal now, right? Yeah, Archana, I'll be discussing the periodicity of discontinuous signals in the tutorial sessions. That is why I told you I'll be just covering the concepts in the theory class. Problems I'll discuss for variety different classes. Okay. For discrete, it will be different. Okay. So this is about even function. Now, what would be the odd function? If you have h of t is equal to minus h of minus t. Okay, now what is meant by minus h of minus t? You must remember any negative sign inside the argument is actually taking mirror image about y-axis. Okay, and any negative sign outside the argument, that is corresponding to amplitude, that is actually equivalent to taking mirror image about the x-axis. Now here it is actually taking mirror image about y-axis as well as x-axis. So if I have a signal like this, if I have a signal like this, similar signal, okay, 3 3. If I take a mirror image about y-axis alone, that will be like this, right? And if I take a mirror image about y-axis also, the mirror image of this will be like this. Okay, so that will be minus 3 here, 3 here, right? So I can draw the signal like this. So this signal, this particular signal will be following an odd function, right? So you can easily check whether a signal is odd or even by checking whether it is following these two equations. A classic example of even signal is, an example for an even signal is cos omega t. We know the function cosine wave is like this. It starts from 1, right? You can see it is with respect to y-axis the image is, with respect to y-axis the image is like this, and classic expression for example for odd signal is sine omega t. Okay, that will be sine omega t will be, this will be like this. I'm just drawing one, sorry. Okay, so this is an example. See, when you take the mirror image of the sine wave, it will be like this. Okay, it will be like this. And if you take again the mirror image about x-axis, it will be like this. So this is twice mirror image, one about y-axis, another about x-axis. This is just mirror image about y-axis alone. That is what is meant by even and odd. Which point I need to repeat? Even and odd? Shalini? Yes. Okay. Any function which obeys this relation, h of t equal to h of minus t is called as an even function. And any function which obeys this relation h of t equal to minus h of minus t is called as an odd function. An example is, say, even means you are just thinking about a function which is having symmetry about y-axis. You can see this triangle, it is symmetric about y-axis. You can see this cosine wave, it is symmetric about y-axis. That is called as even function. Mathematically, it will obey h of t equal to h of minus t. Odd means it will not be just symmetric about y-axis. You first take the mirror image about y-axis, then take the mirror image about x-axis, then you will get a signal, right? Such a pattern, if you obtain, that kind of signal will be an odd signal, right? This is an odd signal. This sine wave is also an odd signal. See, this sine wave, if I take the mirror image first, this is the sine wave. What will be the mirror image? The mirror image will be something like this, right? Again, if I take the mirror image about y-axis, it will give me this particular wave, right? So if I cut down this is a sine wave which is an odd function. Is it clear now? Is it direct things now? Clear? Okay, right. Now I'll list out some properties of even and odd functions. These are important. Okay, first one is, if you have any particular function h of t, you can always split it into, h of t can always be split it into two parts, which is even part and odd part. Okay, I can always split a signal into its even and odd part. How do you do that? If you want to get the even part and odd part, you'll just take the negative of t here. What will be h of minus t? This is equation 1. This is equation 2. I know if I put minus t here, this will also be, should also be converted into argument, should be negative, right? So this will be even part of minus t. I am considering this to be the even part. So even part of minus t will be hc of t itself, right? Odd part of minus t will be h of minus t, correct? Because odd function is h of minus t equal to minus h of t, right? Minus h of t. You can see it here. H of minus t will be minus h of t in odd function, right? So that will be minus h of t, right? If I add up these two signals, 1 plus 2 will give me, 1 plus 2 will give me hc of t equal to, right side will be 2 times hc of t, right? 2 times hc of t will be equal to h of t plus h of minus t, h of t plus h of minus t, which means I'll have the even part given by h of t equal to 1 by 2 into h of t plus h of minus t. Okay. Similarly, what if I subtract second equation from first equation? What will be the result? If I subtract second equation from first equation, the right side will give me 2 times h of t, correct? 2 times the odd part equal to h of t minus h of t, h of minus t, correct? So what will be h of t? H of t will be equal to half into h of t minus h of minus t, half into h of t minus h of minus t, right? So these are two equations to get the even and odd part of a signal. The first equation is given by this formula. Okay, this is the first formula and this is the second formula. This is how you get even and odd part of a signal. We'll see an example. Okay, we'll see the this particular problem, this particular property using an example. I'll take a particular signal h of t. Let us consider the signal h of t equal to 2 for t between 0 and 2 and minus 1, sorry, plus 1 for t, let us say minus 2 to 0 otherwise. Okay, if this signal, if I plot, this is a signal which is having an amplitude of 2. This is a signal having an amplitude of 2 in the positive side, and it is having an amplitude of 1 in the negative side. For minus 2 it is 1. Okay, 1 second. This is minus 2. Okay. Now you'll see this is a general signal. My idea was I can always split it into two. H of t can always be split it into two parts. One part will be even in nature and the other part will be odd in nature. How do you get the odd part and the even part? That is the question. To get the even part, it is very simple. Even part is obtained as half times h of t plus h of minus t. Okay. So how do you get the even part here? This is h of t. Now what will be h of minus t? What will be h of minus t? H of minus t is just the mirror image of h of t. Always it is same. H of t and h of minus t, if you want to draw, you just observe h of t and take the mirror image. It will give me h of minus t. Okay. So this will be h of minus t. H of minus t will be, this part will go to the right side. So it will be 1 here. Okay. And it will be 2 here. So this is h of minus t. Now, if I add up these two signals, what will be the result? The result will be, you can see from minus 2 to 0, from minus 2 to 0, 1 is the value here and 2 is the value here. 1 plus 2 will give me 3 and an amplitude scaling of 1 by 2. So the value will be 3 by 2, correct? 3 by 2. Now from 0 to 2, the amplitude is 2 here and 1 here. So if I add up these two, 2 plus 1, 3. Again, the amplitude is scaled by 1 by 2. So that will be 3 by 2. So this is how I get the even part of this particular signal. Now, how do you get the odd part? Let us check how do you get the odd part. Odd part is obtained as h of t equal to half into h of t minus h of minus t. Okay. So I have h of t here. This is h of t and this is h of minus t. If I subtract these two values, what will be the result? Let us see. 1 second. Okay, if I subtract these two values, 1 minus 2, it will be minus 1, correct? And scaled by 1 by 2. So that will be minus 1 by 2 here. It will be minus 1 by 2 here. Minus 1 by 2. And 2 minus 1, that is 1. 1 into 1 by 2 is 1 by 2 here. Okay. So there will be 1 by 2 here. So this is the odd part. This is odd part and this is even part. You can see the symmetry of the even signal and the odd signal. And what if I add up these two signals? I should get back h of t, correct? You can check 3 by 2 plus 1 by 3 by 2 plus minus 1 by 2. That will be 1 here. 2, 3 by 2 plus 1 by 2 will give me 2 here. So if I add up these two signals, I'll get the resultant signal h of t back. I hope this is clear. Is it okay? Shall I proceed? Yes. Any doubts? Okay. Now some properties I'll list out for even and odd functions. This is very important. These are the properties of even and odd functions. Okay. Properties of even and odd signals. Properties of even and odd signals. Even and odd signals. Okay. The first property is, if you multiply an even signal with an odd signal, the result will be, can someone say what will be the result? It will be an odd signal. Okay. Second property is, if I multiply an odd signal with another odd signal, the result will be an even signal. Okay. And the third property is, yeah, Adra, you're right. If I multiply an even signal with again an even signal, then the result will be an even signal. Okay. Examples are, so if I multiply sine, let us say sine 2t into cos 2t. Okay. So I can say this is an even signal, right? And this is an odd signal. What is sine 2t into cos 2t? Sine theta into cos theta is actually 1 by 2 into sine 2 theta, right? So that is 1 by 2 into sine 4t. The result is an odd function, correct? The result is an odd function. What is odd into odd? You know, sine 2t into sine 2t will give me sine square 2t, right? That can be written as 1 minus cos 2t whole divided by 2. Cos 2t is an even function. Any DC scaling will not change an even function. Okay, any DC scaling will not change an even function, which means suppose I have an even function like this. Okay, this is a rectangular function. This function I can write, this is 1 into rectangular function of t by 4, correct? Amplitude is 1. It is existing from -2 to +2. So if I add 3 to this, what will be the result? The result will be, actually, the result will be, see, I'll have 0 will be added to 3. So this will be the result. Okay, all these values are zeros. 0 plus 3, 3. All these values are ones. 1 plus 3, here will be 4, here will be 3. So you can see this is still an even function, correct? So I can say fourth property as an even function plus a DC value will give an even function, correct? Even function plus a DC value is an even function. Am I right? An even function plus DC value is an even function. Similarly, here it is an even function plus a DC value. So odd into odd is even. Naturally, even into even, cos into cos, that is cos square 2t. So that is equal to 1 plus cos 2t by 2, right? That is also an even function, right? Even plus DC value is an even function. All these are properties of odd and even functions. Now I'll write down one more property which is very important. That is, the area of an odd function will be 0. Okay. The fifth property is area of odd function will be 0. That is, if I have a function from -a to +a, f of t dt, that will be equal to 0 if f of t is odd. If f of t is odd. For example, suppose I have a signal like this. This is an odd signal, 2, -2, 1, -1, right? This area will be positive and this area will be negative. So if I add up this, the area will be 0, right? And the last property is area of even function. Area of even function will be, that is double. That is, if I have -a to +a, f of t dt, that is equal to 2 times integral 0 to a f of t dt, right? That is, if I have an even function like this, for example, if I have an even function like this, see, let us say -2 to +2, this area is positive, this area is positive. So the area from -2 to +2 is actually equal to 2 times 2 into this single area, right? That is another property of even and odd function. So there concludes the properties of even and odd signals. Is it clear to all of you? Is it clear to all of you? Any doubts? Okay, I'll just cover causal, non-causal, and anti-causal signals also. Okay, causal, non-causal, and anti-causal signals will be covered in the next slide. Right. Since this is clear, I'm moving on to the next topic. Causal, non-causal, and anti-causal. Okay, causal, non-causal, and anti-causal signals. So what is meant by a causal signal? Any signal which is 0 for h of t exists only for t greater than 0, and it is 0 for t less than 0. Such a signal is called as a causal signal. Such a signal is called as a causal signal. Okay. Now, what is an anti-causal signal? Anti-causal signal. Just the reverse. So I'll draw the causal signal example. If I consider a signal like this, if I consider the signal like this, see, this particular signal, it is existing from t greater than 0 onwards, and it is 0 for t less than 0. This is a causal signal. Now, what is anti-causal signal? Anti-causal signal is h of t exists only for t less than 0 and 0 for t greater than 0. Okay, t greater than 0. Such a signal is called as an anti-causal signal. An example is, it will be like this. Okay, this part is 0 and this part is alone exists. Now we have a third class of signal called as non-causal signal. See, you must understand, non-causal means it does not belong to the class of causal or anti-causal. Okay, that is, the signal will exist for all values of t. H of t will exist for both t greater than 0 and t less than 0. An example for that is that class of signal is like this. Okay, this is an example of an non-causal signal. So we will be using the terms causal, anti-causal, and non-causal in signals and systems a lot of times, especially in communication systems. So you must understand, causal means it will be existing only for t greater than 0. Anti-causal means it will be existing only for t less than 0. Non-causal means it will be existing for both t less than 0 and greater than 0. One more thing you must remember, these definitions of causality, anti-causality, non-causality in the case of signals is not the same for systems. For systems, causal and non-causal means different things. Okay, that will explain during the classification of systems. For the time being, you must understand, causal signal means it is a signal which exists for t greater than 0 alone. Anti-causal signal means it is a signal which exists for t less than 0 alone. And non-causal signal means it will exist for both t greater than 0 and t less than 0. Okay. So I think, okay, we need to cover energy, and one more class will be required actually for covering signals classification systems, because one important section is energy and power signals, and system classifications we have not started. So those portions will be covered in the next Wednesday's class, and we'll conduct one tutorial sessions for both this. Okay. Now, since this is 1 hour session, I am winding up now. Do you have any doubts? I'll stop the recording, and if you have any doubt, we can clarify it now. Any doubts you can ask now.